Designing an aircraft can often be a very time-consuming, laborious, and overall just painful task to go through. Or at least it used to be, until technology allowed us to dumb down yet another process so you can decide whether or not your souped-up Batmobile with wings is actually going to be able to fly if you built it. That's right, folks! No longer will you have to go get a degree at Georgia Tech to know whether or not your really messed up designs are going to work, because you now have the aircraft designer. A design that takes all the complex equations that would normally require several weeks to calculate for a concept, and simplifies it down to 6 basic inputs regarding performance of an aircraft. Essentially, if you can guess, or maybe if you know, the mass of your aircraft, how big you want the wings to be for the span in the area, how fast you want it to go, what altitude you want it to fly at, and then how quickly you want it to fly to there, you can actually calculate an aircraft that is airworthy and get all the different parameters you need to answer the question, is it actually going to fly? So if we go ahead and run this script, we come to our very first design decision, which is, what kind of tail does your aircraft have? Now at this stage, the tail isn't very crucial in calculating a lot of drag components, so you could really answer one, there's not a wrong answer. So I'm going to go ahead and put in V-tail, because that happens to be my favorite tail. So it's going to go through, do some calculations, and bam! You get your answer right off the spot. You get Will Smith, which means yes, it can fly, because, I mean, he's pretty fly. There's no debating that, no questioning that judgment. So along with Will Smith, you get an output of a recommended airfoil that the function actually calculates for you. So if you decide to design this thing further or possibly build it, you have a good working base to design your wings off of in the future. Along with the airfoil, it gives you 2 different graphs regarding the airfoil's characteristics that can be used to calculate things further. However, more importantly, are the values given in the workspace, which completely correspond to the calculations or the inputs that you put into the program in the beginning. It gives you the angle of attack that you need to have in order to fly at this kind of a rate of climb, the maximum ceiling you can go to, some parameters on the fuselage, the distance that you would need to land in meters, as well as the lowest speeds you could possibly fly at without falling out of the sky. And then, most importantly, is your answer at the very bottom. Will it fly? And the answer is a resounding yes, as indicated by Will Smith. However, if we were to just end the program here, we couldn't really call it an aircraft designer. I mean, all you did was just punch in some stuff to a calculator. You might still want to get your degree if that's all you can do. However, we've gone ahead and attached yet another program to it from a CAD called OpenVSP, which is actually a way to geometrically design aircraft. And so what OpenVSP can do in conjunction with MATLAB is it takes your inputs and goes ahead and uses a pre-existing aircraft, one that we actually created a little bit earlier using a T-tail. It's going to go ahead and take the data that you used, that you created using your 6 inputs, you designer you, and it's going to create your aircraft right there before your very eyes. Then you have the option of shading it afterwards if you want it to look really cool, look more like a drone, because this one happens to be a drone. And from there you can actually see the data that you got from the function put into a real, actually airworthy aircraft. In spite of what you might think, if you were to actually build this thing to the parameters given by the function, it will fly, which is ultimately answered by the question, will it fly? So this program is pretty easy to use, as you can see. I mean, as long as you can pick out these basic values, you can essentially create your own aircraft. So for seasoned aerospace engineers, this saves you several weeks of going through your basic conceptual phase of designing an aircraft and gives you an output of what it might look like if you were to build it. And for anybody else that knows a little bit less about aircraft, you now have something really cool to brag about to your friends. And I think that's why we're all here. For bragging. Alright, that's aircraft design.